Hello friends, today we'll start with polynomial and we'll try to understand all the properties of a polynomial, types of the polynomial. Okay, so you must have studied in the previous classes algebraic expressions like this or like this as well, like 3x plus 5, x square minus 3x plus 4, x cube plus 2x square plus 4x plus 5. We have studied that if the highest power of if the power of the variable is a whole number, then we can say the given algebraic expression is a polynomial. So the basic condition for any algebraic expression to be a polynomial, the power of the variable should be a whole number. Okay, so we'll start with first type of polynomial, that is linear polynomial. So the first example that I gave is linear polynomial, and there is a standard equation all the polynomials. So for linear polynomial, the standard equation is ax plus b, where a and b are constant and x is a variable. Similarly, in case of quadratic polynomial, the standard equation is ax square plus bx plus c. Similarly, a, b, c are constant here. A, b and c are constant, where x is a variable. While in case of cubic polynomial, the standard equation is ax cube plus bx square plus cx plus d. Again, a, b, c, d are constant here and x is a variable. So these are the three types of polynomial that we will discuss in this chapter. So ax cube bx square plus cx plus d is the standard equation of cubic polynomial. Now, depending upon the power of the variable, like in case of linear polynomial, it is 1, where nothing is written over the variable, it means its power is 1. So in case of linear polynomial, the highest power of variable is 1. It will have only one solution, or one zeros or one roots. So if we have some example of linear polynomial, that is the case. For quadratic, this will be the example, and for cubic, this will be the example. So example of linear polynomial is 2x plus 4, or example of quadratic polynomial is x square minus 5x plus 6. For cubic, it is x cube plus 3x square plus 7x plus 6. Okay, now as we have discussed, the highest power of x variable in case of linear polynomial is 1, so it will have 1 zeros or 1 solution. In case of quadratic polynomial, it will have 2 zeros, 2 roots or 2 solution. Similarly, in case of cubic polynomial, it will have 3 roots, 3 zeros or 3 solution. So so these words zeros, roots or solution, so you will hear these three words quite often. So what do you mean by zeros, roots or solution of a given equation, given polynomial? We'll discuss that and we'll come to know what do you mean zeros, what is the meaning of zeros, roots and solution. Okay, so let's move ahead and try to learn the meaning of zeros, roots and solution. So geometrical meaning of the zeros of the polynomial is that the graph of the polynomial will cut the axis at a given point. Like in case of a linear polynomial, if we talk about the linear polynomial, so in case of linear polynomial, where the standard equation is this and example is this. So in case of linear polynomial, it will have only one roots, and if we try to draw the graph, like you must have drawn in class 9th or classes, so the graph will be a straight line, and the graph of the linear polynomial is a straight line, and to find the points on the graph we can simply draw a table where 3x plus 5 is equal to y. So x and y can be kept like this, and you can choose any value of x for which you will get the corresponding value of y. Suppose you choose the value of x is 0, you will get value of y is 5. Similarly, if you choose the x 1, you will get y 8. If you choose x is equal to 2, you will get y 11, and similarly if you get y is equal to 0, you will get x is equal to minus 5 upon 3. Okay, so if you try to draw this graph like this, where this is a y-axis and this is x-axis. So if you mark some points on the graph 1, 2, 3, 4 and 5 and so on. Similarly on the y-axis we can have some different scale like 2, 4, then it will have 6, then it will have 8, then 10. Okay, for x is equal to 0 it will be 5, so it will be somewhere like this. For x is equal to 1 it will be 8, so it will be somewhere here. For x is equal to 2 it will be 11, so it will be above it. For x is equal to 0, for x is equal to minus 5 by 3 it will be 0. Okay, so we will get this point on the negative x-axis. Okay, so let's try to join all of these points. Okay, so this is the line. So in case of linear polynomial you will get a line where the line will cut the x-axis at a one point only, and this point can be found by graphical method as well as by algebraically. We can solve and find the value of x where it will cut the x-axis. Okay, now the graph of the quadratic polynomial is already given to us. So in the first graph, in this one, the graph is cutting the x-axis at 2 points, so it will have 2 roots or 2 zeros, or the graph will cut the x-axis at 2 points, so the value of the quadratic equations will be 0 at these 2 points. Okay, and similarly here in this case as well we will have 2 roots, and but second situation the graph is touching the x-axis exactly at 1 point, so it will have 1 zeros, and the zeros will be, so it will have it is a quadratic equation, so it will have 1 zeros. Okay, similarly in this graph as well, in the next graph, so in this graph as well it will have only 1 zeros, in this graph it will have 1 zeros, in this graph it will have 2 zeros, and in this it will have 2 zeros. Okay, so how can you identify that number of zeros in a linear polynomial or quadratic polynomial or cubic polynomial? Simply we need to look at the graph, and if the graph is given to us we need to look at the graph and we need to check where the graph is cutting the x-axis, where is graph intersecting with the x-axis. It may be in the positive direction or negative direction of x-axis, but if the graph is cutting the x-axis at 1 point, it is a linear polynomial graph. If it is cutting the x-axis at 2 points, it is a quadratic. If it is cutting the axis in 3 points, then it is a cubic. Okay, let's try to solve few more questions based on this. Okay, so any quadratic equations will have graph of 2 type only, either it will be this or this. It will be a open upward or open downward. So graph of the quadratic equations will be a parabola in all the situations like we have just seen. So all of these are parabola equations. Okay, so whether it will open upward or open downward, that will depend upon the value of a. And what is the a? The a is the coefficient of x square, as we have already discussed in quadratic equation, where a is the coefficient of x square. That is the same a. Okay, now this is the exercise. It is for you to solve all these questions. Okay, so you can pause the video here and then try to solve all these questions. So the first graph is cutting the x-axis at 1 point, so it will have only 1 zeros. The second one is cutting the x-axis at 2 points, it will have 2 zeros. Here it is cutting the x-axis at 3 points, so it will have 3 zeros. Here again it is cutting at 1 point, so it will have 1 zeros. Here it is touching the x-axis again at 1 point, so 1 zeros. Now here you can count in the sixth graph 1 2 3 4, so it is cutting the axis at 4 points. So by looking at the graph you can easily figure out number of zeros, or whether the graph is of linear equation, linear polynomial, quadratic, or cubic. Okay, let's move on. Now we need to find the relationship between zeros and coefficient of a polynomial. If we talk about linear polynomial here, so ax plus b is equal to 0, and if we try to solve this, so x will be equal to minus b upon a. So we can get the value of x by simply putting this minus b upon a, and it will have only 1 zero because the highest power of x is 1. But in case of quadratic equation, if we talk about quadratic equation, as we know, the standard equation for quadratic polynomial is ax square plus bx plus c is equal to 0, and here a, b, c are constant and x is a variable. So as we know that x square means the highest power of x is 2, so it will have two roots. If we suppose one is alpha and another one is beta, so there is a relationship predefined for zeros and coefficient of a polynomial. So as we have given here, so alpha plus beta, that will be equal to minus b upon a. So sum of the roots, so we have relationship for sum of the roots, alpha plus beta minus b upon a. Similarly for product of the roots, so for product of the roots, alpha beta is equal to c upon a. And what are these a, b, c? So a is the coefficient of x square, b is the coefficient of x, and c is a constant. Suppose if we know the value of alpha plus beta, and if we know the value of alpha beta, so we can directly plug this value into this given equation, into this equation, and we can get the quadratic equations. And if we know the value of alpha beta, suppose if we know alpha is equal to 4 and beta is equal to 3, so we can simply write x minus alpha, x minus beta is equal to 0, and we can solve these equations to get the quadratic equations. Or if we know the value of alpha plus beta and alpha beta, we can simply put this into the given equation, and kx square, where k can be eliminated because it is common to all the terms. And next move on to cubic polynomial. So for cubic polynomial, if we talk about cubic polynomial, for cubic polynomial, the standard equation as we know is ax cube plus bx square plus cx plus d. So in case of cubic polynomial, it will have 3 roots because highest power of x is 3 here. So it will have 3 roots, alpha, beta, and gamma. Here the relationship is given here. This is for the given, and here it is given sum of the roots. Here it is given for sum of the roots. Here it is given for sum of the product of the roots. Sum of product. and in this case product of the roots. So these are the relationships given for linear polynomial, quadratic polynomial and cubic polynomial. So we will see how we can find out the zeros of a polynomial and how we can relate, how we can verify that the given relationship between zeros and coefficient of polynomial, is it actually the same or a bit different. Now we have a question: find the zeros of the quadratic polynomials and verify the relationship between zeros and coefficient. So if we need to find the zeros of the quadratic polynomial, we'll write like x square plus 7x plus 10, and we can solve these equations by factorization. And in case of factorization, we have some algorithm. Like step 1, we first of all compare that equation with the standard quadratic equations, and we get the value of the coefficient. Here a is equal to 1, b is equal to 7, and c is equal to 10. So the first step is to get the value of mod AC, and the mod AC here is 10. In second step, what we do is we factorize. We find the factor of AC. To find the factor of AC, so we'll find the factor of 10. 1 is 110, 2 5. Okay, and the third step is we'll find the sum of or difference of the roots. So sum or difference of the root should be equal to the middle term or the coefficient of x. So that is middle term split as well. We have studied in previous class, that is a middle term split method or factorization method to find the roots of the quadratic equation. Okay, so 2 plus 5 is 7. Okay, so we'll put this into the given equation. X square plus 2x plus 5x plus 10 is equal to 0. We'll take the x common out of the first two, so it will be x plus 2 only, and we'll take the 5 common out of the last two, so it will be x plus 2 again. Now from the given equation, we'll take x plus 2 common out, so it will be and x plus 5. And if we try to solve both of these equations, compare them with 0, so we will get two values of two roots of the quadratic equations. So we can say any one alpha and the other one is beta. We can take minus 2 as beta and minus 5 as alpha. That not going to change anything. Okay, now we have find out the roots of the quadratic equations. We'll see the relationship. So relationship is alpha plus beta is equal to minus b upon a. Okay, so alpha plus beta, so we'll write alpha plus beta minus b upon a. That is the relationship that we have already figured out. So alpha is here minus 2, beta is again minus 5, minus b. So b is 7 here, so it will be minus 7. A is 1. So you can see the both sides of the equations are same. So we have find out the relationship sum of the root is equal to the minus b upon a. Now the product of the roots. So we'll minus 2 minus 5, and that is equal to c upon a. So c is 10, so 10, 1 is a is 1, so 10 upon 1 is equal to 10. So we have exactly find the sum of the roots and product of the roots, and we have verified that the given result is similar equal to the roots or product of the roots that we have find by simplifying the given equation. Okay, next move to the okay, so we have exercise here. We'll try to solve few questions from the exercise. Okay, so the first we'll try to solve fourth one, fifth one, and third. Okay, so let's solve the third. All other you can do by exercise in exercise, and if you do not find the answers of first, second, or sixth, you can simply write in the comment box. I'll answer the remaining part as well. So we'll try to solve first question, third question, that is 6x square minus 3 minus 7x. Okay, so here 6x square, so we'll write the equation in similar to the standard equation form, where standard equation was ax square plus bx plus c. Okay, now as we have already discussed, so a here is 6, b here is minus 3 minus 7, and c here is minus 3. Okay, so first step is multiply AC. So mod of AC is 18, so we'll find out the factor of 18. So if we try to find the factor of 18, so it will be 118, 29, 36, 4, 5 will not be the factor of, and then 6, which I have already solved. So 118, 29, 36, and the middle term is 7. So these two will form a solution to the middle term. So 6x square minus 9x plus 2x minus 3 is equal to 0. So minus 9x, because the middle term is the coefficient of x is minus 7. Okay, so we'll take the common out from the first two. So the common will be 3x, so it will be x minus 3. We'll take the common out 2 from here, so it will be x minus 3. Okay, so it will be 2x minus 3. Okay, let's try to solve. So we'll take the common out from the first two. So we'll take the 3x common out from the first two, so it will be 2x minus 3, and from here we'll take the 1 common out because nothing is common out here. Okay, this is 2x minus 3, 3x plus 1. We compare both these, we compare these two with 0, so we will get x is equal to 3 by 2 here, and x is equal to minus 1 by 3 here. Okay, now we can verify that sum of the roots 3 by 2 plus minus 1 by 3, that should be equal to minus b upon a, and b here is 7, so minus minus is plus 7 upon 6. And if we solve the left hand side, so we'll take the common 9 minus 2, so that is also 7 by 6. Okay, so we have solved it correctly because the sum of the roots is equal to 7 by 6. Okay, now we will try to find the product of the roots. So alpha beta, alpha we have just find is 3 by 2 plus 3 by 2, and beta we have already discovered minus 1 by 3. So alpha beta 3 by 2 into minus 1 by 3, that should be equal to that should be equal to c upon a, and c here is minus 3 and a is 6. Okay, and 3 will get cancelled out, so it will be minus 1 by 2, and here again it is minus 1 by 2. So we have clearly figured out that we have clearly verified that the sum of the roots and product of the roots are same. Okay, now we will try to solve question number 4, that is 4u square plus 8u. So if we compare that equation with standard quadratic equation, that is ax square bx plus c, so here a 4, b here is 8, and c is equal to 0. Okay, so because there is no c, so we can solve this quadratic equations directly here. So we'll take 4u common out from the first two, so it plus 2 is equal to 0. One of roots will be u, that will be 0, and the other one will be so one of the root is alpha and the other one is beta. Okay, so we can take any one as alpha, another one as beta. Now we know the relation product of the roots. So first is alpha plus beta minus b upon a. Alpha here is 0, plus minus 2 is equal to minus b is minus 8, and a here is 4. So minus 2 is equal to minus 2. That is verified. Now we'll try to find the other relationship, that is verify the other relationship, that is alpha beta is equal to c upon a. Alpha 4, alpha is 0. So alpha 0 means anything with 0 becomes 0. So that is 0 on the left hand side. On the right hand side c is 0, so that is 0. So relationship is verified. Okay, so let's try to solve one more that we were supposed to solve, that is t square 10.
minus 15. Okay, and if we try to solve this equation, so it will be t square is equal to 15, where t is equal to under the root plus minus 15. So we have again the one is alpha, you can name it root 15, and the other is beta,
so that will be minus root 15, and we can verify the result like alpha plus beta. So alpha plus beta here is minus b upon a, so it will be b upon a, so 15 under root 15 minus under root 15 is equal to minus b. So minus b here is, see that on the left hand side becomes 0, or on the right hand side is 0 as well. Now we will try to figure out the other relationship, that is product of the roots. So alpha into beta, that should be equal to c upon a. So alpha and beta is root 15 and beta is minus root 15. And c here is 15 and a is 1. So on the both side of the equation you will get minus 15. So result is also verified. Okay, now move on to the next question. So next is find the quadratic polynomial each with the given number as the sum and product of its roots respectively. So now sum of the roots and product of the roots is given to us. So if the question is of 1 mark type, it actually depends upon the type of question. If the question is of 1 mark type, we can simply use the given equation which we have already discussed, that is x square minus alpha plus beta x plus alpha beta. Okay, and sum of the roots is given to us, so x square minus alpha plus beta is 1 by 4, alpha beta is minus. We'll solve this equation. It will be 4x square minus x minus is equal to 0. So this is the given. So this is the quadratic polynomial that we can find out by using the given result, that is sum or product of the roots of the zeros is given to us. And if we are not given if the question is type, if the question is not of 1 mark type or 2 or 3 marks type, then we need to apply different technique. In that case we need to solve by long method, like alpha plus beta is equal to 1 by 4, beta is equal to minus 1. So alpha, we'll substitute the value of alpha or beta from first equation to second equation. Okay, so from first equation we get alpha is equal to 1 by 4 minus beta. So we'll substitute that value into the second equation, so it will become by 4 minus beta is equal to 1 by 4, so minus 1. Okay, then we can solve this, will become a quadratic equation, we can solve it. So this will become beta by 4 minus beta square is equal to minus 1, and this will become 4 beta square plus beta is equal to 0, and we can simply change multiply the given multiply this equation by minus sign, so 4x square minus 4 minus x is equal to 0. Okay, so as you can, both the results are same, so you can use any of the methods to find the quadratic polynomials if sum or product of the roots are given to you. Okay, So here we have a next topic, that is division algorithm. So what is the need of a division algorithm polynomial? So the need arises when we are given a cubic polynomial, and cubic polynomial will have three zeros, but if only one zero is given to us, and if we can find one zeros, so what is the method to find the other two? So in that case we'll use division algorithm, and division algorithm is quite similar to the one we have already doing in the previous classes in the junior classes. Okay, so let's try to solve. So x plus 2, 2x square plus 3x plus 1. Okay, so here we x plus 2, 2x square plus 3x plus 1. Okay, so the first step is to eliminate the highest power. The first step is to eliminate the highest power, and this will dividend will be a polynomial px, divisor will be a polynomial gx. Let's suppose quotient will be a polynomial qx. We divided by small or capital letter, that is not going to make any difference. Okay, so we'll try to solve now. So x plus 2, so we need, in order to eliminate the highest power of x, so highest power of x in the dividend is 2, and in the divisor the highest power of x is 1. So if you multiply divisor x plus 2 by x, or by 2x, you can say, so it will be 2x plus. So write down the, okay, so these terms will get eliminated, and here we will have minus x, and this plus 1 will come down, and we will keep on solving till the time we have the power of divisor as well as the power of dividend same. So here x, the power in case of divisor, here x plus 2, that is power of x is 1, and in case of dividend, that is x plus minus x plus 1, so highest power of x is 1 here as well. First step, we'll divide that by 2x, then we'll use minus 1, so minus x minus 2, again minus minus, so get cancel out, and it will become 3. So this is the remainder, and we can denote this by rx. Okay, now we have for few more questions, like if we need to check that if the given first polynomial is a factor of the second polynomial, and as we know, if any polynomial or any number is a factor of the other polynomial or a number, then it will divide the other one completely. So factor divides the number completely. If we have a factor of a number, so factor will divide it completely. Okay, so we'll try to check it out with by division algorithm method, by division method. So first one we have t square minus 3. Here we have 2t to power 4. Here we have 2 t to power 4 plus 3t cube minus 2 square minus 9t minus 12. Okay, so highest power of x is 2 here, and in case of dividend it is 4. So we'll multiply that by, and in coefficient we'll multiply that by 2. So we'll have 2 to power 2 to t to power 4 minus 6 t square. Okay, so minus, and it will minus, sign change, so it will become plus, it will become, sorry, minus, and this will become plus, sign change, get cancel out, and this is 3t cube. That is one important point that we need to make a note here. Only the same powers will get added up. Only the term with the same variable power will be added up. Term with the same variable power will be added up, like t cube will be added or subtracted to t cube, t square will be added or subtracted to t square. So 3t cube will remain same. Here it is plus 6t square minus 2t square plus 4t square minus 9t minus 12. In the next, t square is the highest power of divisor, where in dividend we have t cube. So we'll multiply that by 3t. It will become 3t cube minus 90. 3t cube minus 90. Okay, so this will become minus, this will become plus, this will get cancel out. Here we will have cancel out. So we will have only 4t square minus 12. Now t square minus 3, so the power is same, but there is a change in terms of the coefficient. So we'll multiply that by 4. So 4t square minus 12. So both these terms got cancel out, and we get the answer 0. So what does this mean? It means that t square minus 3 is the factor of 2t power 4 plus 3t cube minus 2t square minus 90 minus 12. Okay, so you can try to solve the other two parts, and if you find difficulty in solving the other two parts, you can write that in comment, and we can try to solve the as well. That is now we have the most important questions. That is a very important question. It is generally asked in board exams, both for CBSE and ICSE. So two of the zeros of the polynomials are known to us, while we need to find the other two. So as we have already discussed, we can find out the polynomial using these two zeros. So we can use directly x square minus alpha plus beta x plus alpha beta square minus, so these two are same, so it will become 0, and if you multiply these two, so it will be 5 by 3. Okay, and now what we need to do, we need to use the division method to find the other two roots. So we'll divide the given polynomial by x square minus 5 by 3. Minus 5. Okay, so the highest power of the divisor is 2, whereas the highest power of the dividend is 4, so we'll multiply that by, and for coefficient it will be 3. So the first term becomes 3x ki power 4, and 3 will get cancelled out, so it will be 5x square. Sign change. We just discussed that x cube will be only added or subtracted to x cube only. Similarly, x square will get subtracted to x square. So this term 6x cube will remain same. Neither it will be added or subtracted to any other term because there is no term of cube. And plus 5x square minus 2x square plus 3x square minus 10x minus 5. Okay, now the highest power of divisor is 2 and the highest power of the dividend is 3, so we'll have a difference of x. Okay, so we'll use plus for coefficient 6x, so this will become 6x cube, and 6 5 is 30, but we'll multiply 3 and this will get cancelled out, so it will be minus 10x. Okay, sign change, minus plus, this will get cancelled out and this will get cancelled out. Here we have 3x square minus 5. Now we can see that highest power of divisor and dividend is same, so we'll simply use coefficient plus 3, so 3x square minus 5. Now we have the quotient of the solution, quotient of the division. So we'll try to solve this quadratic equation. So here we have 3x square plus 6x plus 3. The steps that we have already defined. AC is A here is 3, B here is 6, and C here is 3. So if we compare the given equation with the standard quadratic equation, we will get the value of ABC. So AC is 9, and since AC is 9, and one more thing that we can do, because 3 is common to all the terms, so we can take 3, remove that 3, so it will be bit easier to solve. And here we can see that it is nothing but x plus 1 ka whole square. So the other two terms that we get here, other two zeros that we get here is minus 1 and minus 1. So we get to the conclusion that we have 4 zeros of the given equation, 3x ki power 4 plus 6x cube minus 2x square minus 10x minus 5, and these 4 zeros are root 5 by 3 and minus root 5 by 3, minus 1 and minus 1. Okay, in the next part we can, if we simply assume divisor as gx, like here it is quotient qx, remainder Rx and dividend Px. So like in the normal division, like we have in very junior classes, primary classes, we have like if you divide for 20 by 4, so we 520 here, and so Px, that is 20, is 5 into 4 plus 0. So that is quite similar to the we have been doing in the previous classes. Okay, so we can try to solve this question and then verify the division algorithm in the similar way. Okay, so let's try to solve. Okay, so first of all, try to write the equations in the standard equations form, like highest power first, very highest variable first, then the next, and then next. Okay, so try to write down that in standard equation form. So x square plus x minus 1, here minus x cube plus 3x square minus 3x plus 5. So highest power of x in the divisor is 2 and the highest power of x in the dividend is 3. So we'll multiply by, so this will become minus x cube plus x square minus x. Sign change, x square minus plus 5. Now we'll multiply the dividend by, we'll multiply the divisor by minus 2. So this will become minus, sorry, plus minus 2. Okay, so this will be plus 2x square minus 2x plus 2. Sign change, this will be minus, this will become plus minus. So this will get cancelled out and this will get cancelled out. We'll have 3 here. Okay, and if we try to use the basic theorem like Px